Hello and welcome. Today we'll be talking about the rampant growth of AI, which has become an incredibly hot topic, and are going to use the improvement of chess AI to draw conclusions on where AI is headed in relation to its human creators. The first instance of a computer beating the best human at anything happened in 1996, when IBM's Deep Blue beat Garry Kasparov. This was the first time a computer showed to be better than all human achievement combined. And since that moment, the gap between the best in the world and the best computers in the world has only grown. Even in games that require verbal communication, such as diplomacy, AI was able to perform at a human level. If AI is so much better, then what even is it? AI, specifically standing for artificial intelligence, are computers who are trained through mathematical models to recognize what they're seeing, whether it be recognizing pictures of hot dogs or 30-move chess lines. All the computer is doing is recognizing what it is looking at and computing a response. How does a computer even learn how to play chess? First, computers undergo supervised learning, where it is fed pre-planned images to help strengthen the weight of the computer, or in layman's terms, make it remember what they want more effectively. From there, the computer enters unsupervised learning, where the computer is fed random images, which it sorts through, once again strengthening its memory. Finally, it enters reinforcement learning, where the computer is fed specific information that it has not remembered from the first two steps. What is most commonly called AI right now are actually large language models such as ChatGPT. But these are only a very small, refined niche of what AI and machine learning is. Thinking about AI as either entirely benign or entirely dangerous is a complete waste of time, but being educated on the subject has become an almost necessity. In 1996, Deep Blue had managed to earn a 2,852 rating, 95 points higher than the current world champion at the time, Garry Kasparov. Right now, 27 years later, the best chess player in the world, Magnus Carlsen, has the all-time world record for highest rating at 2,882 points. Currently, the best chess AI, Stockfish, sits at a rating of 3,546 points, or 664 points higher than the best chess player in the world. Why is AI so good at chess? Because it's all memorization. Shannon's number, 10 to the power of 120, represents the total number of possible games when playing chess, which for a human to remember is impossible. For a computer, however, this task is not nearly as daunting. Stockfish today can sort through 2 billion possibilities in a minute, far faster than any human possibly can. Due to this, humans have taken a back seat when it comes to what is the best chess player, now only competing for who. However, the advancement did not come to the disappointment of chess grandmasters, who instead have been using AI to improve how they play constantly. Even though humans invented the machines, now it's the machines that teach the humans how to play. Due to this, the best human players have been improving over time, just not at the same rate as the computers. If we wanted to watch the most technically intense chess games, we would all watch computers play. And AI-only chess competitions have become commonplace in both the world of chess and AI development. But is AI only good at chess? No. As I talked about earlier, AI has grown from simple memorization, which is all chess is to a computer, into something that can talk, strategize, and convince other real people. We saw this happen in 2022 when Cicero, a meta AI project, took on the game Diplomacy, where it was ordered to act as a country in war, making treaties, stabbing allies in the back, the whole 9 yards. The meta team used supervised learning to teach Cicero how to play the game, all with the help of Andrew Goff, the Diplomacy world champion. While the computer was not able to regularly beat the best in the world, it was able to perform within the 90th percentile of players, after only playing a single practice game. The world champion compares humans to Cicero, with a lot of human players often soften their approach, or they'll start getting motivated by revenge. Cicero never does that. It just plays the situation as it sees it. It's ruthless in executing strategy, but not ruthless in a way that enrages other players. Overall, it sounds like Cicero is pretty good at democratizing with real humans, a skill that's eluded our government officials for decades. If computers are already proven adept in both strategy and diplomacy, what reason does the US government have to not use them for things such as military strategy, international relations, global trade disputes, and more? The truth is the US is already using AI, and sometimes in ways I personally am less than comfortable with. One specifically scary growing factor is AI surveillance, such as facial recognition in every country across the globe. A Carnegie Endowment for International Peace study found that in 176 countries, the use of AI to surveil civilians has increased far faster than professionals and researchers thought possible. This is being found in countries considered both democratic and undemocratic. Even worse is what General John Allen of the US Marine Corps warns about with hyperwar, a type of conflict so automated that it will effectively minimize human control over most decisions. The use of AI in war could also lead to an increase in actions available to both state and non-state actors, which to me sounds like a computer finding possibilities to kill the enemy in ways we have never thought possible. How do we deal with the morality of atrocities committed by computers if we cannot even properly process atrocities committed by humans? Would it be any more ethical if AI bombed the hospital or if a human general did the same thing? Today, AI is far from calling the shots in the US military, and overall is still quite simple. The most effective uses for AI are all hyper-specific and extremely helpful to researchers in specified fields. AI is extremely helpful when it comes to sorting through massive amounts of data, whether it's searching for new planets and stars that would be completely inaccessible for human astronomers, or generating designs for antibodies we have been unsuccessful in developing on our own. The closest thing we have to true artificial general intelligence are GPT transformers, which will deliver answers to questions of any category in pre-designed structures. The reason this AI is so far from being scary to us is that these transformers are still merely placing pre-recorded data into natural-sounding answers, which is little more than read the shadows against the wall, if we draw a metaphor to Plato's cave. This leaves us feeling safe for now, but how long will that last before we push what's possible with AI just a little too far?